Okay, folks, we're on to part three here, the atmospheric dilemma. This is a little bit of a play on the prisoner's dilemma because it's actually the prisoner's dilemma underneath this, which is a game theory concept. And so we'll look into this. Now, game theory is part of economics, but it's a little bit different than, it's also part of political science. It's a little bit different from those, the price quantity, market model, because in this context, we're trying to model situations where we know that it's not one individual person facing sort of like a vast sea of producers or consumers. It's like me thinking about what to do when I'm playing a game with like one other person, right? And so what's best for me to do from thinking about my own sort of interests depends on what I think is best for you and what you are going to do in light of your interests. And so there's this like strategic interdependence that we're trying to get at in game theory modeling. So now the prisoner's dilemma is basically the story goes like there's these two thieves and they get caught, and then the detective like puts them in separate rooms and gives them a deal whether to and the choice is to confess or stay silent. And both of the thieves are essentially sort of they're given that same choice, and there are payoffs, different payoffs due to either of these choices, right? But we're talking about climate change, and I think so. I'm not going to use the prisoner's dilemma. I don't want to have you thinking too much about that, and instead, I want you to imagine two major powers in the globe. I'm not going to specify. I mean, you could think about this as like the USA versus China. You could think about this as the global North versus the global South. You could even think about this as like one generation versus another, right? The folks my parents' age who were sort of in charge of the global economy when they put up all the greenhouse gases to begin with, and versus me and my kids, my soon to be born daughter, for example. And at the end of the day, the choice is to basically act or don't. Are you going to act to spend some money to transition the global economy away from fossil fuels? To figure out regenerative agriculture that puts carbon in the ground, to fix all the methane leaks, et cetera, et cetera. Or are you not? Are you going to let somebody else do that? Are you going to just pretend that the problem doesn't exist? And you can see why there might be some sort of gamesmanship to this. And so the way that we're going to think about this is in a typical game theory grid. So again, we're going to use a simple sort of 2x2 kind of matrix here, and we're going to have the A country, and we're going to have the B country here. And to make it sort of clear the stakes here in each of these quadrants, well, first of all, each of these rows corresponding to A and each of the columns corresponding to B is a different choice. So A can either act or not act. That's the logical symbol for not. It's just negation, right? And similarly, B can act or B can not act. And to show like what's at stake in each of these situations, each of these quadrants, right, defines a action choice, a set of actions that the two players take. Up here it's A acts and A acts and B acts. Et cetera, et cetera. So, but the payoffs of action are different, and so each of these quadrants has, a sort of area that's associated with each of the actors. So I'm gonna paint these in just to make it really clear. And what defines a prisoner's dilemma as a prisoner's dilemma actually is, or a dilemma of this sort that is known as the prisoner's dilemma, is actually the structure of the payoffs. So let's say that the payoffs here that I'm going to write in are in trillions. Those are the expense, which is about the size of numbers that countries might take account of. So let's suppose that down here, if neither act, they are both out $2 trillion. If neither, if both act, they both incur the costs of mitigation, but they're out less damage. But then if A chooses not to act and B chooses to act, B basically takes on all of the climate change investment, and let's say that A basically spends no money and in fact gets to expand their economy in a way that B couldn't, so they basically break even. And let's suppose that that this is sort of the a symmetrical kind of situation. That if B chooses to not act, hey, A, you can do it. A takes on all that cost, and B breaks even. The numbers in particular don't matter, but the numbers in relationship to the other numbers is what makes this a prisoner's dilemma. So I want you to think, though, for a second, like what assumptions are underneath this? What assumptions do we have to make to have this sort of represent an accurate portrayal of the situation that we find ourselves in, sort of global politics around greenhouse gases? What assumptions do we need to make for the atmospheric, which is prisoner's dilemma, to be a good model of global climate change politics? Do you think it is? Do you think it's not? What elements of it seem to fit this kind of description?